Welcome! Today, Motion Control Quick Start 18, how to use Pulse Motion Controller. And in this video, it will be introduced from these 4 parts. The whole process from wiring to motor execution. It can be seen that includes many details. After learning this knowledge, all controllers with pulse axis can be used in this way. For EtherCAT controllers, please review our former video, Motion Control Quick Start 16, and corresponding article. Okay, let's start. At first, what we need. For hardware, of course, we need one pulse motion controller. Here, we use ZMC412, a 12-axis pulse controller, and one set of servo drives and motors. Also, it must be with pulse port. Here, we use Panasonic. Then one PC, 124 volts DC power supply, and other cables, terminals as needed. If we need more iOS or even Axis, expansion modules can be used. For software, we need controller development software ZDevelop. It can be downloaded from website or contact us directly. Then using servo drive debugging software to set drive parameters. Please download it from Panasonic website. After we prepared all these materials, it is time to learn basic information about them. Here, the MC41 to pulse motion controller. It supports 12 pulse axes. Obviously, there are 12 pulse axes here, and corresponding axis numbers are shown. If we need more, 32 axes can be expanded. It is one high-performance controller, so rich motion control functions are valid, including simple and complex functions. What's more, real-time motion control can be realized through optimized network communication protocols. For communication, it provides several interfaces: Ethernet, USB, CAN 232, 485. Next, let's see the main wiring of this controller. First one, power supply. It only needs to connect D plus 24 volts to positive pole and connect EGND to negative pole. It can be seen there is one other FG, which is used to connect with shield shells. Second one, Ethernet port is to communicate controller with PC. One cable is okay, but the cable is better to be with shields. Third one, pulse axis interface is to connect controller and drive. Specifically, link controller axis to drive X through one specialized shielded cable because it is Panasonic A6 drive. If there is no corresponding pulse axis interface on drive, please make the cables apart. Then wire according to behind method. One axis has 26 pins. This form shows each pin definition and function. It includes pulse axis and encoder terminals. For pulse axis, pin 9, pin 11, pin 22, and pin 23. For encoders, pin 4, pin 5, pin 6, pin 17, pin 18, and pin 19. As it was talked, use one cable. If no relative terminal, they can be connected directly. Please connect them according to this through connection cables. Here, pin 3 should be noted. Generally, it is used to enable out in axis. That is, opening out 12, enabling drive on axis 0. Open out 13, enabling drive on axis 1. Even if it not only has one out in each axis, also has 12 out itself. They are with different output numbers. From out 0 to out 11 are controller general outputs as output signals. From out 12 to out 23 are controlling axis outputs as enabled signals. Okay, how to connect them in details. Actually, there are 2 methods because the terminal includes pulse and encoder. That is, pulse wiring and encoder wiring. And both includes differential connection and single-ended connection. Let's see pulse terminal wiring firstly. For differential connection, connect positive and negative of pulse and direction 1 to 1. Compared to differential ones, single-ended one is more complex. Connect these 2. Then connect drives pulse plus and direction plus terminals to controller 5 volts. These 2 are not used. Except the simple and complex differences, there is another main difference. Former one is to see the voltage difference. So both will change. The difference will not be big. But for behind one, only one will change. Power voltage will keep the same. Then the difference will become bigger. Therefore, differential one has better anti-interference ability than single-ended. Then, using the encoder terminal, our Zmotion controller pulse axis only can be connected to 5 volts encoders. If there is only 24 volts encoder, the ground cable is EGND, and only some controllers, I/O terminals can support. Please check it through the hardware manual. Also, there are 2 ways for 5 volts encoders. For differential, connect correspondingly. For single-ended, connected encoder, ABC to controller EA+, EB+, EZ+. Please note both need grounded, and it must be axis grounded, not I/O grounded. Let's see examples for knowing clearly. Pulse terminals and encoder terminals are connected. This one belongs to low-speed differential connection. This one is high-speed differential connection. The difference is the pulse pin connected. Others are the same. By the way, the wiring of drives and motors or encoders. Please refer to the driving manual. Well, from now on, we have learned the hardware wiring. Next, let's see how to connect our pulse controller to PC. Usually, there are 2 methods, serial port or net port. Here, we mainly see the Ethernet method. For Ethernet, connect them through one cable at first and power on controller. Then open our ZDevelop. Open the Connect to Controller window. It can be seen this window shows 3 connect. Ethernet, we use the second one IP. That is, correct IP must be selected. If there is no needed IP, we can scan it and select it. Here, local IP means PC IP. Please observe PC IP and controller IP. Front 3 must be the same. The last one must be different. Then they can communicate. When IP is selected and their IPs are OK, click Connect. In Output window, it will show corresponding information. This means success. And at this time, we need to confirm whether the controller is correct again. However, sometimes their IP cannot meet communication requirements. That is, they are not in one same network segment. We need to modify them. Modify controller IP or modify PC IP. If we choose the first one, there are also 2 methods. Before that, we need to know controller IP through serial port connection, then through Windows or commands. When the IP changes, it takes effect all the time. If we want to change PC IP, open Network and Sharing Center. Find Internet. Click Properties. Then open this one. Select second one. Now, we can fill in the new IP. IP is changed after OK. Next, do the connection again. Full above steps. Usually no problem for connection. Next part is some simple but important parameters configuration. Specifically, access type and access number settings. First one, A type. This parameter was talked in detail in Start 14. Here, mainly for pulse axis. Still, refer to this form. For pulse motors, A type should be set as 1 or 7 or 4. Default is 1 or 7, and it doesn't include encoder, which means encoder measurement signal is not here, but for other axis number. Then it will be DPOS value. If we set it as 4, real encoders can be connected. At this time, encoder feedback and pulse axis are for one same axis, so MPOS gets real feedback. However, for bus axis, DPOS and MPOS are for one axis. Except the pulse axis type selection, we need to set the pulse output mode for it. It only needs to set this command. There are dual pulses, pulse plus direction, and quadrature pulses. Default is pulse and direction mode. This one is to check current mode. Therefore, correct axis type must be set, and it is usually in initialization. Second one, pulse axis number. For pulse axis, drive number depends on connected controller pulse axis number. They are 1 to 1. If controller axis 0 is connected, motor axis number is also 0. Then we can send commands to axis 0 for controlling the motor. So no need for axis mapping. For bus axis or other iOS expansion modules, axis mapping is required. But we mentioned no encoder. MPOS and DPOS are not for one axis number. Then if we want to know which axis number gets the encoder feedback of axis 0, please open controller state window. In this window, all related information are here. In axis features list, it shows each pulse axis pulse and encoder usage situation. Step encoder means this axis supports pulse output and encoder feedback. When A-type is 4, both are valid. Encoder means this axis is for measurement. Here, axis 8 to axis 11 are to get the encoder feedback. And the default axis type is 3. Therefore, before using, it is better to check controller state for axis number. And different controller models are with different allocations. This shows ZMC for 3.2. ZMC for 3.2 has 6 pulse axes on the board. Then pulse axes are from 0 to 5. Encoder axis numbers are from 6 to 11. That is, the first pulse axis interface axis 0 has axis 0 pulse output and axis 6 encoder feedback. Axis 1 has axis 1 pulse output and axis 7 encoder feedback. For ZMC for 1.2, it has 12 pulse axes on the board. So axis 0 to axis 11 are pulsed. Axis 16 to axis 27 are configured as encoders. Then mapped into encoders of axis 0 to axis 11. That is, if axis 0 connects to the encoder. The axis 16 obtains the feedback. If now a type of axis 0 is set as 4, axis 0 outputs the pulse, also gets the feedback. Generally, this axis number configuration is enough if we don't need other specials, like change the axis number of itself. Use special in. If yes, please refer to the corresponding article or contact us. While setting, we not only set for controller, but also set for driving. As it was mentioned, using driving software. At the beginning, connect drive to PC. Here, we use USB cable, power on drive, and then open drive software. Here, Panasonic is Panaterm, because we use USB to connect. There selects this one. Then current drive information is shown. If no problem, click OK. It is time to set parameters. Click Parameters, then corresponding information appears. We can select the parameter type here. After selecting one certain parameter, details are shown in yellow part. Then we can set directly. Please remember to click Enter for saving the new value. For example, if drive I/O setting is not correct and it leads position limit alarm, or we need to set position limit level reverse, select Type 4. It is for iOS only. Double-click Set Value. Fill in the value. In this way, it sets successfully. If we want to make parameters restore factory values, it only clicks this one. In addition, we can set several values at the same time. Then save them into drive storage. That is, this one. Click Transfer. Then click EEP. When all are transferred, click OK. Power on driving again. Now, new values take effect. We can open this window to check them. If we encounter driving alarms, there are 3 ways to solve. First one, in our ZDevelop, check access status parameters, or check the alarm information in the output window. Second one, see drive. If there is error indication in LED, error code also will be shown. Then check manual for specific errors. Third one, see drive software alarm information or history alarm. And in this history alarm window, reasons and solutions are shown. Okay, let's see how to use pull axis in real connection. The reference is still 1ZMC for 1 to +1 servo drive. The motor is with encoder. Here, using axis 0, connect pulse output signal and encoder input signal to controller axis 0. At this time, the motor axis number is 0, and the A type is 7. Then encoder axis number will be axis 16. The A type is 3. Therefore, axis 0 MPOS is not true because it is 7. It will follow with DPOS. If it is 4 or bus type, MPOS is real feedback. Here, real MPOS is axis 16. That is MPOS of axis 16 reflects on DPOS of axis 0. DPOS of axis 16 is false because axis 16 is encoder axis. After axis type and axis number are correct, it is time to enable pulse axis. Actually, it is enabled by out in axis. ZMC for 1-2 has 12 pulse axes and has 1 output in each axis. So general outputs are 0 to 11. Outputs in axis are 12 to 23. Then open out 12 to enable axis 0. A sound appears, generally enabled. If we want to confirm the enabling situation, when there is safe, rotate the motor axis by hand. Rotated means disabled. Next, do axis parameters initialization. After that, it can execute homing. For homing, it uses controller homing mode, which was talked before. Do too complex pulse wiring. Before running really, we can try to run by manual in ZDevelop. While debugging, it is recommended to set a small units, then increase it slowly. In this process, we can view whether there is a problem. If yes, that is, the motor can T-rotate. Then we can check following these steps. Step 1. See DPOS value. If it is still, which means the controller has no pulse sent, then see axis status value. If it is not 0, see specific problem. If it is 0, current state is correct, but axis type may be wrong. Set type is 1 or 7, then manual again. If the DPOS value changes, which means the controller sends the pulse normally, then see whether the axis is enabled. That is, see the corresponding OP port. If it is opened, enabled, then check whether there is encoder. If yes, see its MPOS and A type. MPOS changes. It is moving, but the units is too small. If there is no encoder or MPOS doesn't change, please check A type and set again. If A type also is correct, the problem may be the wiring. So this is one whole problem checking process. When there is driving alarm, please clear it, then check. If the motor only moves in one direction, check and modify the control mode through commands. After all are okay, download Motion Control Program to execute. Here, axis 0 is used. Then all parameters and commands are for axis 0. Let's run one move 200. Here, OP12 is open to enable axis 0. While running, use oscilloscope to see running situations. We need for data, axis 0 DPOS and speed M speed. Axis 16 MPOS and speed M speed. Axis 16 is the encoder axis reflecting on axis 0. It can be seen DPOS of axis 0 and MPOS of axis 16 are 200. Okay, today's pulse controller usage is over. Thank you for your watching. Also, you could refer to corresponding articles for text and code information. If you want to know about our Zmotion Pulse controller, please contact us. Have a nice day. See you next time.